Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, I know that in the lockdown holidays you have enjoyed a lot with a lot of entertainment activities. Even you had given rest to your mind from school activities as well as school education. Is it not? Now it is a time to coming back to school education to enhance and boost our knowledge. Therefore, the Pi Academy is going to conduct the tuition classes for 9th standard students. In our academy, we are going to teach two subjects. One is mathematics and second one is science. Dear students, in today's class, we will focus on mathematics. Dear students, do you know how many chapters you are going to learn in this academic year in mathematics? Yes, have you ever seen that your mathematics textbook? Okay, if not, nothing to worry, just listen to me. You are going to learn total 15 chapters. How many? 15 chapters. 15 chapters. Now let me go for telling the names of these chapters. Listen carefully, and you will also, I am sure that you will also be able to identify some of the chapters which you have learnt in your previous classes are also there here. Now, the 15 chapters are, the very first one is number systems, second one is polynomials, third one is coordinate geometry, fourth one is linear equations in two variables, fifth one is introduction to Euclid's geometry, sixth one is lines and angles, seventh one is triangles, eighth one is quadrilaterals, ninth one is areas of parallelograms and triangles, 10th one is circles, 11th one is constructions, 12th one is Heron's formula, 13th one surface areas and volumes, 14th one statistics, and the last chapter is probability. That is also very important chapter. Now, okay, shall we begin the class? Yes. Now we will go for taking the first chapter, that is number systems. Before going to that, just let me give you one important information to you all, that is, here we are going to follow the order which has been given by the CBSE board, that is Central Board of Secondary Education. In the same order only we will go for covering the syllabus. And one more information is that in addition with that NCERT, we are also going to follow the two reference books. One is S. Chan and second one is R.D. Sharma. Got it? And dear students, please take a notebook and pen, and you will go for writing the name of the chapter. Before that, just observe here, it is your notebook. In the very first page, index is there. In the index, you will write your name, class, section and all, subject, serial number, 1, date, today's date 11/6/2020, and the name of the chapter, it is number systems. Number system. Then after that, you will open the fresh page, and in that you have to follow this pattern to write the name of every chapter. It looks neat. See, here I have used pencil, a Veda box, and this box is divided into three parts. One for chapter number, second part is for name of the chapter, and third one is for date. Please do follow this. If you are not able to write it now quickly, do one thing, stop video and go for writing, then continue the video. Now, let us go for learning the chapter. The name of the chapter is number systems. I'll write it. This is chapter number 1, and the name of the chapter is number systems. Dear students, To learn this chapter effectively, it is better to recall some of the basic things what we have learnt in our previous classes. Now let us just go for recalling one by one in the introductory part. Right, introduction. Dear students, I'll go for giving you some of the situation that in one situation, assume that in your classroom, your teacher will ask you to count how many desks are there. Then similarly, they'll ask you how many students are there in a particular class and section. And they may ask you how many number of staffs are there in your school. Then in all these situations, that is to tell how many desks, how many students, how many staffs, what you will go for? You will go for counting. Yes, you will go for counting. That counting concept is nothing but number. Hence, we can define the number as a mathematical concept used for counting. Just I'll go for giving you the point. The same thing should be copied. No need to write the definition. Right now, number. Number is a mathematical concept used for counting. Number is a mathematical concept used for counting. Assume that in your classroom there are 15 desks, there are 50 students, and in your school there may be around 60 to 70 or 100 staffs are there. Okay, here I am using 15, 50, 100. So all these are numbers. Orally what I am telling? All these are numbers. To represent these numbers, we have some symbols. These symbols are known as numerals. What are these? Numerals. Suppose I want 15. 15 can be written like this. Don't copy anything. 50 can be written like this. And another one is 100 can be written like this. So these are the symbols which represent the numbers, and these symbols are known as numerals. Got it? Okay, once you listen to me carefully, the definition of numerals. The symbols which are used for representing the numbers are called numerals. Now, again you just go through these numerals 15, 50 and 100. Here, to write the numeral, I have used some more symbols like 1 and 5. Here, to write 50, 5 and 0. To write 100, 1, 0 and 0. To suppose I go for taking 57,684. This is, if I read this 57,684, it is a number. And this is the symbol, and this symbol is called numeral. To write this numeral, I have used some more symbols, and these symbols are called digits. Digits are the symbols used for writing the numeral. The numeral may be small one or bigger one. To write that, we will go for using the symbols, and the symbols are known as digits. Do you know how many digits are there in mathematics? Yes, there are 10 digits in mathematics, and these digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Total 10 digits. So write down. Third one, it is digits, and the digits are, just I will go for writing, please copy them. There are 10 digits in mathematics. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8. And you can go for using the conjunction, and 9. So these are the digits. You done? Okay, then stop writing. Now, we have different collection of numbers. Just I'll go for giving the example, I am going to encircle some of the numbers 2, 4, 6, 8. Immediately you will identify and you can tell that, sir, they are all even numbers. Then I can go for making a collection of even numbers. In the same way, collection of odd numbers, like that. Many are there, which you have already learnt in your previous classes. And in this class, other than these collections, we are going to learn some more collection of numbers under the heading different types of numbers. Write down the side heading. Side heading, different types of numbers. Different types of numbers. Written? Okay, nice. Now, observe. In the very beginning of this chapter, I asked you the number of desks, students and the staffs. If the same task is given to anybody, that is, I will ask how many desks are there in the classroom. What they will go for? They will go for counting them, 1, 2, 3, like that. And this collection of counting numbers, they are called set of natural numbers. Now this is the first type of number. Once I tell you, natural numbers, the counting numbers are called natural numbers. Please go on writing with me. First one is natural numbers. And let me write the definition of natural numbers. The counting numbers are called natural numbers. Done. The counting numbers are called natural numbers. And examples for natural numbers, it is 1, 2, 3, 4, 5, 6 and so on. If you go for writing these numbers as a group by enclosing with a pair of flower brackets, then this collection is known as set of natural numbers. And this set of natural numbers is denoted by the symbol capital N. Got it? Okay. Now, let us go for second one. Here also, I will take some examples. Here I will write the examples for the numbers 1, 2, 3, 4 and so on. No doubt, these are natural numbers. I go for writing including one more. The one more number, which is the great contribution given by the Indians to the field of mathematics. You know that who is the inventor of zero is Aryabhata. So I'll write 0. Now, see this natural numbers including 0, these numbers are called whole numbers. W-H-O-L-E, whole numbers. The natural numbers including 0 are called whole numbers. Write down with me. Whole numbers. Let me write the definition. The natural numbers including 0 are called, here on right, are called whole numbers. The natural numbers including 0 are called whole numbers. So these are the examples. You can copy them. 0, 1, 2, 3, 4 and so on. So this collection of whole numbers is denoted by the symbol capital W. Observe this W, nothing but whole numbers. It includes the natural numbers 1, 2, 3 and 4 and so on. Hence you can say that all natural numbers are whole numbers, but reverse is not correct. That is, you cannot say that all whole numbers as natural numbers. The reason is 0 is not a natural number. Clear? Okay, now we will move on to third one. Again, here also I'll go for taking example. Don't copy. Here I'll write 1, 2, 3, 4, 5 and so on. These are natural numbers. I go for including 0. Then you can say that there are whole numbers. In addition with them, I go for taking the negatives of these natural numbers. What are the negatives? It is negative 1, negative 2, negative 3 and so on. So then we have got a new collection, and these numbers together known as integers. Let me tell you the definition of integers. The natural numbers and their negatives including 0 are called integers. You can also define in another way as the whole numbers including their negatives are called integers. Let's go for writing the definition. Write down. The whole numbers including their negatives are called integers. The whole numbers including their negatives are called integers. And the integers are denoted by the symbol capital I. And one more symbol is used for representing, it is Z. The letter Z has been taken from the German word that is called Zahlen. So you can write down a point. So before that, we have written the definition and copy this example, that is -3, -2, -1, 0, 1, 2, 3, 4, 5 and so on. This can also be written as 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4 and so on. Written up. Now take note, this is an important point. The letter Z comes from the German word Zahlen. The letter Z has been derived from the German word it is Zahlen, which means to count. Copy. Now look here. When you observe the examples of integers, you can come to know that it includes n, nothing but natural numbers. Therefore, natural numbers are integers. It includes w, nothing but whole numbers. So all whole numbers are integers. But reverse is not possible. That is, you cannot say that integers are whole numbers or natural numbers. The reason is -1 is not a natural number. Even -2, -3 or -1, they are all not the whole numbers. Clear up? Okay. Now, we will move on to the fourth important term. Here I will write that. Here I am going to take a number. Please don't copy, keep observing. You may take 5. This number can be written as a fraction. You know that we can write it as 5 by 1. You can write it as 10 by 2 like this, or minus 10 by minus 2 in this way. So here that means this number has been written in the particular form called P by Q form. And observe P and Q, nothing but numerator and denominator. What type of numbers are these? These are, just we learned, they are integers. P and Q are integers. And observe Q. Q is here 1, minus 2 like that. It may be any number except 0. That is Q. It is not equal to 0. Because if Q becomes 0, then it will be undefined term in mathematics. We have value for 0 by 5. That is 0 by 5 is 0. But we do not have any value for 5 by 0. So 5 by 0 is an undefined term in mathematics. Anything by 0 is undefined term. Okay. If a number satisfies this condition, then that number is called rational number. What it is? Rational number. Now let me tell you the definition of rational number. A number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called rational number. Once I repeat, the numbers which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, are called rational numbers. We go for writing the definition with me. Write down. The numbers which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, are called, what are these called? Rational numbers. Okay, let us go for writing the examples for rational numbers. Right. Example, you know that just I told you 5 can be written in the form of P by Q under this condition where P and Q are integers and Q is not equal to 0. So 5 is a rational number. Minus 10 is a rational number. Minus 3 by 5 is a rational number. 17 by 15 is a rational number. 12 by 7 is a rational number. See, these are some examples for rational numbers. Then, what is there about 0? Is 0 a rational number? Yes, because 0 can be written as 0 by 1, 0 can be written as 0 by minus 2, like that. So, where 0 and 1 or 0 and minus 2 are integers and the denominator is not equal to 0. Therefore, 0 is a rational number. There is a chance of asking this question in the examination. Is 0 a rational number? Why? Yes, 0 is a rational number because it can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Clear? Now, rational numbers. This collection of rational numbers is denoted by the symbol Q. Should it not be R? When natural number is N, whole numbers is W, integers is I or Z, then rational number, should it not be capital R? Why Q only? There is a reason. That reason is, when you divide a number by another number, you get whatever the value you get, that is quotient. So here also, rational number is in that form On dividing you will get the quotient. The letter Q has been taken from the word quotient. Right? The letter Q has been derived from the word quotient. The letter Q has been derived from the word quotient. Therefore, rational numbers is denoted by capital Q. So, then here still we have different types of numbers. Before that, they have given some of the questions, some problems with respect to rational numbers. Now let's move on to those answering those questions. Look here, and along with that, I want, before going to those questions, I give you one more information. That information is whether when you go for taking a rational number, does it have unique representation? What do you say this? Means, suppose 1 by 2 is. Do you say that 1 by 2 is always 1 by 2? Yes, certainly 1 by 2. But is it possible to write in other form? 100%. It is. See that 1 by 2 can be written as 50 by 100. Can be written as 11 by 22. Can also be written as 25 by 50. Can also be written as 5 by 10. See that. So, here we have written a number 1 by 2, it's a rational number, then it has been represented in different ways. Then what do you say about the rational numbers regarding their representation? Are they unique? No. Rational numbers do not have unique representation. Rational numbers do not have unique representation. Please note down this. Then if it is so, then what do you call these numbers? See, these are, when you go for simplifying these numbers, again you will get the same 1 by 2. So these numbers are called equivalent rational numbers. You have learned about equivalent fractions in your previous class. The same way. Right. Rational numbers do not have unique representation. Right. Rational numbers do not have unique representation. Unique representation. Why? It is because of the existence of equivalent rational numbers. Just for the sake of information, in bracket I write because of equivalent rationals. Now, you can go for taking example for this. Same thing. 1 by 2 can be written as, it is 5 by 10 can be written as 25 by 50. Then you can write 30 by 60, 100 by 200 and so on. Written, huh? Okay. Now, let me give you one more point. That is also very nice. Here, I'll take the rational number which is in the form of P by Q, 3 by 7. I'll take another rational number, it is 2 by 3. One more, 7 by 4. See, all these are rational numbers. They are all in the form of They are all in the form of P by Q. Then observe P by Q in these examples. 3 and 7, 2 and 3, 7 and 4. What do you say? What do you say about their common factor? Yeah, what is the common factor of P and Q? Nothing but 3 and 7. It is 1. What about common factor of 2 and 3? That is also 1. Common factor means the number from which the given numbers, that is P and Q, can be divided. That is a factor. Then I am asking you, what is that factor? Here, 7 and 4 are not at all divisible by any number except 1. In any rational number, if P and Q do not have a common factor, then P and Q are called, what do you call? They are called co-primes. Please do remember this point. Co-primes. Right. This is also one of the important point to be remembered. Right now, in P by Q, if P and Q do not have common factor, other than 1, then P and Q are called co-primes, which I have already learnt in 6th standard about co-primes. A pair of numbers which are not at all divisible by any number except 1 are called co-primes. Or a pair of numbers whose HCF is 1 are called co-primes. Listen, and one more point. Suppose you go for representing 5 by 10 on the number line, 25 by 50 number line. Like that, infinite number of equivalent fractions are available. To represent them, any of these infinite numbers, if you represent 1 by 2, that is enough, because they are all equal to 1 by 2. Okay. Now, I will go for taking NCERT text. In that, they have given some of the questions. Let us go for answering. Right. Side heading. Answer the following questions. Answer the following questions. In that first one. In first one only, they are given 3 sub questions. The question is, are the following statements true or false? Right. Are the following statements true or false? Put question mark. And give reason for your answers. Give reasons for your answers. Give reasons for your answers. First one, I'll go for writing. They are given every whole number is a natural number. First question is every whole number is a natural number. Do you agree with this statement? They have given that we can call all whole numbers as natural numbers. Is it right? What do you say? Whether it is true or false? Yes, it is false. Why? See, don't write the answer, just observe. I'll go for writing the whole numbers. Every whole number, 0, 1, 2, 3 and so on. He is telling that every whole number is a natural number. No doubt. 3 is a whole number and it is also a natural number. 2 also natural number. 1 also natural number. What is it about 0? Is it a natural number? No. Therefore, the given statement is false. Right. Answer: it is false. Why it is false? Because 0 is not a whole number. Sorry, 0 is not a natural number. Right down here. Because 0 is a whole number but not natural number. 0 is not a natural number. Here. Now let us go for answering second one. Copy them quickly. Second one is, it is every integer is a rational number. Every integer is a rational number. Do you agree with this statement? Every integer, and go for writing some of the integers like -2, -3, even 0, 1, 10, 12 and so on. All these are integers. Can you consider all these integers as rational numbers? See, no doubt. Why? Because -2 can be written in the form of -2 by 1. -2 can be written in the form of -4 by 2. See that? That means -2 can be written in the form of p by q, where p and q are integers and q is not equal to 0. Similarly, here also you may go for taking any number. Clear? Yes. Then what is say? Whether the given statement is true or false? It is true. Right. Answer: it is true. Why it is true? Because every integer can be expressed in the form of p by q. Because every integer can be written or can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. This is answer for second question. Now one more. Third sub question is there. I'll move on to this. Third sub question is reverse of this statement. Here they are given every integer is a rational number. Then reverse of the statement is every rational number is an integer. What do you say? Of course it is false. Here I'll write every rational number is an integer. Every rational number is an integer. Every rational number is an integer. Answer: what do you say? It is false. Why? See, every rational number is an integer. Now I'll write 2 by 3. It is in the form of p by q. Then here, usually the integers will not be in this form. They'll be having only the numerator. Here I'll write because integers. Because I'll write taking one example. Minus 2 by 3 is a rational but not an integer. This will be better. Better now? Okay. In the first question, we have 3 sub questions. Now, we will move on to the next type of problem. That side of that, right. Observe here. Here I'll write 0 and 1. 0 and 1, they are rational numbers. Between these two rational numbers, how many can be written? Here I'll write 0. It is, I can write 1 by 4, then 1 by 2, 3 by 4. Between 1 by 4 and 1 by 2, again plenty of numbers can be written. Between 1 by 2 and 3 by 4, many can be written. So here we are going to find out number of rationals between two given rational numbers. Right. Second question. Second, instead of taking, just write worked examples. In that first one. Find any 4 rationals between 1 and 2. Find any 4 rationals between 1 and 2. Let us go for finding them. Now you stop writing and look at them. Here we have different methods. One of the method which has been given in the textbook will be introduced now. Look here. You are going to find out 4 rationals between 1 and 2. In the method, if 4 are going to be found out, then we will go for adding 1 to 8. Like this. 4 plus 1 is 5. If 10 are to be asked, then we will go for 10 plus 1. Like this it will be continued. Now 1, without affecting 1, we have to express 1 in P by Q form. Like this. 1 is to be multiplied by 5 and is also divided by 5. See, 5 by 5 is 1. 1 ones are 1. Now multiply only numerator. 1 into 5 is 5. Divided by 5. 5 by 5. Then I will go for taking 2. 2 into, again, this 5. Multiplied and divided by 5. What is 2 5s are? It is 10. Then denominator 5 as it is. Don't go for simplifying, because on simplifying you will get the same number. 5 by 5 is 1. 10 by 5 is 2. But we want 4 rationals. Observe, 5 by 5 and here is 10 by 5. Between these, some rationals are there, we can go for writing them. 5 by 5 is there, next one is 6 by 5, next one is 7 by 5, like that, 8 by 5, 9 by 5, then 10 by 5. Now could you tell what is 5 by 5? 1. 10 by 5? It is 2. Now between 1 and 2, how many are there? 4 rationals are there. Therefore we can write the conclusion as, therefore the 4 rationals, don't copy, first observe, the 4 rationals between 1 and 2 are 6 by 5, 7 by 5, 8 by 5, 9 by 5. These are the 4 rationals. Then just go for copying this. First, see that how many rationals are going to be found out. Here then ask 4. Add 1 to it, you will get 5. 4 plus 1 is 5. Then multiply 5 to the numerator and denominator. Then don't go for simplifying. Instead, multiply numerator 5 with 1. 1 5 is a 5. Denominator as it is. Even take another number 2. Multiply again 5 and divide it by 5. You will get 10 by 5. Then between 5 by 5 and 10 by 5, these are there. Copy them and write the conclusion. Over. Now, just I'll go for taking one more example. Shall I? If it is over, then observe. Find any 6 rationals. Find any 6 rationals between 5 and 7. Here I have taken consecutive numbers. Now here I have taken non-consecutive numbers. Let us go for finding the solution. What is the first step? You can recall it. If 6 rationals are going to be found out, then add 1 to it. How much it becomes? 6 plus 1 is 7. And what is the next step? Yes, 5. Write 5 as it is. Then multiply 7 to the with 5 and divide it by 7. Now multiply only numerator terms. 5 sevens are 35. 35 by 7. Okay. Now take second. Write 7. How do you write? 7 into 7 by 7. This 7. 7 by 7. It's equal to 7 sevens are 49 divided by 7. Then between 35 and 7, between 35 by 7 and 49 by 7, how many are there? Many are there. 36 by 7, 37 by 7, 38, 39, 40 and so on. Many are there. So I will go for writing like this. Means the number of rationals between these two is more than they have asked. Hence I can write in this way. 36 by 7, 37 by 7 and so on. Last one is 49 by 7. Between these two, we want only 6 rationals. Let us go for writing them in the conclusion. Write it. Therefore, the 6 rationals between 5 and 7 are, you can go for writing any 6. Here are right. Continuous 6 numbers. 36 by 7, 37 by 7, 38 by 7, 39 by 7, 40 by 7. 1, 2, 3, 4, 5. And write one more. And 41 by 7. Still many are there. Over. Okay. Now, I'll go for taking one more example. But this time, see, in the first example, we took consecutive numbers. Second, we took non-consecutive number. Now, I am going to take negative numbers or negative integers. Here I'll write. Third one, copy with me. Find any 5 rationals between -2 and -3. Let us go for finding them. Again, follow the method what I told. That is, you are going to find out 5 rationals. So, what should be added? 1 should be added to 5. How much you get? 6. Now, second step, write it. -2, this is equal to, now we have to multiply and divide 2 by 6. Then -2 multiply 6 and divide by 6. Now multiply only numerator. -2 into 6, -12 divided by 6. Next, -3. -3, it is -3 into 6 by 6. Again, minus 18 by 6. Now we have to write the number of rationals between these two. Then how do you go for writing? Here -12 by 6 is there. Now next one is good. -13 by 6, -14 by 6, and so on up to -18 by 6. Where -12 by 6 is -2, -18 by 6 is -3. Between them we want 5. Let us go for writing them. Therefore, the 5 rationals between -2 and -3, -2 and -3 are, what are those? We can go for writing these. -13 by 6, -14 by 6, -15 by 6, -16 by 6, and -17 by 6. So these are the 5 rationals between -2 and -3. Clear? Just recall the problems what we have taken. First we took 2 consecutive positive numbers. In second problem, 2 non-consecutive positive numbers, positive integers. Now this time we have taken negative integers. Now I go for taking one more type of problem, and this type is also very simple. You are going to find out the rational numbers between 2 rational numbers. These 2 rational numbers will be in the form of P by Q. I am going to take the textbook example only. It will be easier. Let us move from simple to complex. That is, from easier problem to the difficult one. So that now, right, it is fourth one is find 5 rational numbers or rationals between 3 by 5 and 4 by 5. Written up. Then observe the word. How many rationals are going to be found out? 5. What is the method I told? If 5 are asked, we should add 1 to it. Then it becomes 6. But is it applicable for this type problem? Here P by Q form numbers are there. Of course you can apply, but one thing you must remember, it can be applied if the denominator terms are same. Here Denominator is 5. Here is also 5. Now, I go for right. 5 is there. 5 plus 1. It is 6. Then take the number 3 by 5. Are you all writing? Yes. Then 3 by 5. What should be done? Multiply 6 to the numerator as well as denominator. 6 by 6. What is 3 6 are? 3 6 are. It is 18. 5 6 are 30. Now, one more number. It is 4 by 5. It is equal to 4 by 5. Again multiply 6 to the numerator as well as denominator. 4 6 are 24. 5 6 are again 30. Now look here. 18 by 30 and 24 by 30. Between them, how many are there? Count it. 19, 20, 21, 22 and 23 by 30. Right? Yes. Let us go for right. 18 by 30, 19 by 30 and so on. 24 by 30. You are going to write the rational numbers between these two rationals. Let us write. Therefore, the 5 rationals between the given numbers 3 by 5 and 4 by 5 are 19 by 30, 20 by 30. If you want, you can go for simplifying it or just keep that as it is. Because see that 20 by 30, 0, 0, it becomes 2 by 2. 21 by 30, 22 by 30, 1, 2, 3, 4 and 23 by 30. So these are the 5 rational numbers between 3 by 5 and 4 by 5. Finished up? Okay, now listen to me again. Again you have to recall the problems. First problem, two consecutive numbers, positive numbers. Second problem, two non-consecutive positive integers. Third one, negative integers. Then in fourth one we found rationals between two rational numbers which are in the form of p by q with the denominator term same. Now how to find out the rationals between two rationals if the denominator terms are different one? Yeah, this is also very important. Obviously this type problem can be asked in the examination. You have to put star mark and then go for writing. Right. Copy. Fifth one. Find any 6 rationals between, I go for taking 5 by 21 and 3 by 14. Observe, the rational numbers are 5 by 21 and 3 by 14, where the denominator terms are different. If it is so, then can we go for applying the same method like this? 6 is there. Shall we go for adding 1 to it? Will not be suitable. The reason is, if you want to find out them, if you want to find out the rationals between two given rational numbers, the denominator terms must be same. Now, here what I'll do is, observe, let us make the denominator terms same. To make that, you should go for taking the LCM of the denominator. LCM of the denominators 21 and 14 is how much? If you know, you can write it directly. If not, Then go for finding. Here I'll show you that 21 and 14. These two numbers are divisible by 7. 7 3s are and 7 2s are. Where 3 and 2 are not at all divisible by any other number except 1. Hence you multiply 7 into 3 into 2. It's equal to 7 3s are 21. 21 2s are 42. So LCM is 42. Now it is very interesting that you are going to write the given rational number such that the denominator term should be 42. Here, look here, 5 by 21 as it is, it's equal to, as I said, denominator should be 42. Then what should be multiplied with the 21 to get 42? 21 2s are. If you do not know, you can do one thing. Here in the working column, write that rational number as it is. 5 by 21, multiply LCM 42. 21 ones are 21, 2s are. Write that 2 in the denominator as well as numerator. Multiply 5 2s are 10, 21 2s are 42. I hope that it is clear. Next, another number 3 by 14. As I said again, 3 by 14 multiply LCM to that number. 14 ones are 14 3s are. Here is 3. Multiply that 3 with both the numbers. 3 into 3, 14 into 3. What is 3 3s are? 9. 14 3s are 42. Now see the 10 by 42, 9 by 42. Between them, how many are there? We find it difficult to tell because after 9, next 10 only is there. Under such condition, you can go for multiplying and divide to this number by any other number. For to make it simple one, you may go for taking 5, 10, 20, 30, whatever it is. I'll go for multiplying and dividing by 10. Now, what it will be? 10 tens are 100, 42 tens are 420. Then this is also 10 by 10. 9 tens are 90, 42 tens are 420. Between 90 by 420, 100 by 420, many are there, right? That is, many are there, but how many we want? We want only 6. Let us go for writing them. 90 by 420. 91 by 420 and so on, 100 by 420. Now, alright, conclusion. Therefore, the 6 rational numbers, I hope that you are all writing with me, the 6 rationals between 5 by 21 and 3 by 14 are 91 by 420, 92 by 420, 93 by 420, 94 by 420, 95 by 420 and how many? 1, 2, 3, 4, 5, one more. 96 by 420. So these are the 6 rational numbers between 2 rational numbers 5 by 21 and 3 by 14. So before going to stop the class, just let me tell you one thing, one important thing. Please, whatever the syllabus we go for every day, practice them on the same day itself. Please don't keep anything pending. If you work out on the same day itself, you find it easier to follow the further classes. As I said, this is important one. It must be practiced many times. And definition of rational number is also. So with this, let us stop the class. Thank you very much. Let us meet again in the next class.